Hello everyone, welcome to this course on structure, stereochemistry and reactivity of organic molecules and intermediates, a problem solving approach. Okay. In the last session, we have discussed the cyclization rules, which are commonly known as or popularly known as Baldwin rules. These rules are basically employed to predict the outcome of an intramolecular cyclization reaction, involving a nucleophile attacking a carbon with a leaving group or attached via a multiple bond like a double bond or triple bond. So, we have seen different types of cyclization possibilities like exocyclization or endocyclization, and then we have seen how the rules predict that certain cyclizations are not favored, that is disfavored, and certain cyclizations are favored. These are not forbidden or disallowed or allowed by any symmetry rules. That is not the case. It is basically a favored process and a disfavored process. Okay. Today, this session I will do some problems based on where Baldwin's rule have been applied. We will see that and then move on to other topics. Okay. The first problem, first of all, let me try to point out that when you talk about Baldwin's rule, there are different types of ring sizes, 3 to 7, that is the normal ring size. Then these exo and endo possibilities, and then the hybridization of the carbon. So, it is a exotate or exotrig or exodig, all these possibilities are there. So, sometimes students become confused that about how to remember these rules. So, what I suggest is basically you concentrate on the disfavored processes. Okay. If you know which processes are disfavored, then automatically you know which processes are favored. So, better concentrate on or try to find out what is disfavored. Okay. Now, if you see that, there are two types of again rules I have pointed out, that is, one is basically the the ring size, then exo or endo, then tate or trig or dig. That is one type of cyclizations, and the other one is where an enolate is involved in the cyclization. So, the nucleophile is coming in the form of an enolate, okay, where there are ambident nucleophiles, nucleophilic centers possible. Okay. So, the first one is that the disfavored ones are this. So, if I say D means disfavored, so 3 exo dig, usually exocyclizations are favorable, but for diagonal system, that means sp hybridized carbon, the rules are little different. 3 exo dig and 4 exo dig, these two are disfavored. Okay. And the other ones, the endo ones, that means here the endo ones are favorable, like 3 endo dig or 4 endo dig. Okay. And that is why I am saying just concentrate on one, that is what is disfavored. Okay. So, that is one type, that involving cyclization at a sp hybridized carbon, and the other one is 3 to 7 endo tate cyclizations. Okay. Endo cyclizations are usually difficult at tetrahedral carbon and trigonal carbon. So, what is really disfavored is 3 to 8 endo tate cyclization and 3 to 5 endo trig cyclization. Okay. So, there is a difference here, both are endo. So, when it is happening at a tetrahedral carbon, then all sizes are disfavored, because I told you in my previous lecture that until you reach a ring size of 9, the nucleophile cannot approach, is geometrically not possible for the nucleophile to approach exactly from the back side of the leaving group. Okay. So, that is why it should be 3 to 8, but as per Baldwin's rule, because he mentioned the ring sizes of 3 and to 7. So, we are restricting to that size. Okay. And for trigonal cyclization, 3 to 5 endotrig is disfavored. That means, when you say 6 endotrig, that should be favored. Okay. That is possible. So, these things you should remember. And for the other type, that enol, that is the enol endo, and then you have exotate, that is another type of cyclization. Remember, that is basically that you have a something like this, O minus. Okay. So, now this is what is enol endo exotate. Okay. So, if you think of that type of cyclization, then what happens? 3 to 5 ring size involving enol endo exotate is disfavored. So, 3 to 5 enol endo exotate, that is disfavored. Okay. And so also enol endo exotrig, that means, if you have instead of tate, if you have trig, that is also, you can say that this is also disfavored if it is 3 to 5 enol endo exotrig. Okay. So, that means, when you have the enolate double bond attacking in an endo fashion, then 3 to 5 ring size is disfavored. Okay. Beyond that, it is possible, that is favored. Okay. And that immediately tells that enol endo, enol exo and exotate or enol exotrig, these are actually favored processes, because we are not mentioning that, we are just picking out the disfavored processes. So, again I repeat, disfavored processes involving non-enolate systems, that is 3 exo dig and 4 exo dig. So, we can combine 3 to 4 exo dig cyclizations are disfavored, and then 3 to 7 endotate and 3 to 5 endotrig are disfavored. In case of enol endo systems, then enol endo exotate and enol endo exotrig, here 3 to 5, if you are making 3 to 5 is the ring size, then these are disfavored. Okay. Beyond that, things become favorable. Okay. So, let us now start doing the problem session. So, this is the basic rules that I remember. So, let us do the first problem, and that is this one. Okay. Okay, this is an alpha beta answer, paramethoxy, then this double bond. This is not cinnamate, this is paramethoxy substituted, paramethoxy phenyl substituted alpha beta unsaturated carbonyl system. So, if you want to attempt a cyclization like this in a Michael fashion, okay. Now, you have to make a powerful nucleophile, and that is by the use of a base. So, if you use a base like potassium tertiary butoxide, okay. So, that will make the O minus. However, there was no reaction. So, the anticipated type of addition to give a 5-membered ring is not possible. Actually, this is forbidden by the this is not forbidden, sorry, this is disfavored as per the Baldwin's rule. Again I repeat, it is not a forbidden by any symmetry, that is why we are not using the word forbidden or allowed. It is basically we are saying favored and disfavored. Okay. Now, this cyclization, if it had happened then that classify that cyclization. This cyclization will be, first of all, the ring size will be 5, and this is an endocyclic double bond. So, 5 endo, and this is a trigonal carbon. So, 5 endo trig. Okay. And we have the rules here, 3 to 5 endo trig is disfavored, okay. And that is why this reaction is not going. So, as simple as that. However, if you now add acid in presence, if you want to do this, you can do this cyclization or attempt this cyclization in 2 different ways. Either increase the nucleophilicity of the attacking nucleophile, that is the OH. So, you want to make O minus, that is one way. The other way is to increase the electrophilicity of the double bond, that you can do by adding acid. Okay. So, if you add acid, then that will protonate this carbonyl, and this protonated alpha beta unsaturated carbonyl system is even a better Michael acceptor. Okay. So, more electron deficiency is created at the beta carbon. Now, in this case you get the product. So, the product, the anticipated product is formed here. Okay. So, what is the difference between the acid and base, and how it is possible to whether this reaction, this product has been formed as per the Baldwin's rule or following the Baldwin's rule, let us see. So, actually what happens here, that before this wedge attacks, this OMe, because of this it is a donor. So, this type of delocalization will take place. Okay. So, that creates a new structure. Okay. So, that creates a new structure. Let me try to write that. So, this is OH. So, this is the other resonance form, double bond, then a double bond, and you have the aromatic ring OMe plus. Okay. So, this is the other resonating form. Now, what will happen? Now, this wedge, now this wants to again gain back the aromaticity. So, this wedge can now attack this carbon, the same carbon, but now the electron flows in the opposite direction. This is a double bond which is exocyclic, okay, as per this 5-membered ring. So, that goes there, this goes there, and the methoxy, which was the oxygen was positive, now it has satisfied the charge and the ring becomes aromatic. So, this will generate the anticipated 5-membered ring, and then OMe, and this cyclization, now you can classify this cyclization as 5-exo trig. Now, which is now favored, which is a favored process, because this is the rule, 5-endo trig is not favored, but 5-exo trig is favored process. Okay. So, that is why this is now possible, this type of cyclization is possible. So, now only thing is that you have to tautomerize the enol into the carbonyl, and that is the final product. Sorry. So, nothing is violated, this product is following the Baldwin's rule. The only difference is that because of this resonating structure, now you can have an attack by a by a favorable 5-exo trig process. Okay. So, this is one example. Okay. Then you have, suppose there is a system like this, that you have a unsaturated carboxylic acid, but it is not a conjugated carboxylic acid, the double bond is somewhere else. Now, this is very common reaction, that if you add iodine here, then what happens? It forms a lactone. That means, the carboxy adds to the double bond. Now, there are 2 possible positions of attacked by the carboxy. So, the mechanism is that it forms an iodinium ion and then CO, OH. So, either the OH attacks at this position or it can attack the this carbon and opens up that one. Okay. Now, which one is possible? Actually, which one will happen as per Baldwin's rule? Now, remember, if you have this 3-membered ring opening like the epoxide ring opening, then you have some problem to define the reaction as exo or endo. So, what I suggested that when it attacks this carbon and opens up this, think this as it was originally a double bond. Okay. So, your double bond carbon is actually the double bond and is basically exo to the ring that is formed, that is being formed. Okay. On the other hand, if this attacks the second carbon, this one, then if you think this as nothing but originating from a double bond. So, if you consider the double bond as a proxy, then that bond is going in this direction, okay, and that is basically an endocyclic attack. Okay. So, when this breaks, that is the exo, when this bond breaks, that is the endo. Okay. So, now you define these two processes. Suppose this process is process A and attack at this carbon is the process B. Okay. So, the process A is the size of the ring is 1, 2, 3, 4, 5. So, that is 5 exo, because I have told you that is actually exo, 5 exotate, okay, that is the pathway A, and pathway B is 6 endotate, 6 endotate. Okay. So, obviously, 6 endotate falls under this, so which is a disfavored process, and if it is disfavored, so that product will not be formed. So, the product that will be formed, you can write that is this one, carbonyl, oxygen, this, and there will be an iodine here. Okay. If it is coming from the alpha side, because the carboxy was originally alpha, so the iodine should be beta. Okay. So, that is another example of where the Baldwin's rule can be applied, and you get the iodolactone. This is the iodolactone as per the 5-exotate process. Okay. So, this is the second one. Now, let us see what other problems we have. Okay. Now, this is an interesting example that you have a triketone like this. Okay. And you are trying to do an intramolecular aldol reaction, okay, intramolecular aldol reaction by employing say a base. Okay. Now, because there are so many carbonyls, the possibility of different enolates and possibility of different types of cyclization are there. Okay. So, which product will be formed? Now, let us see these two hands are basically same. So, you can form enolate of one hand and the enolate attacking the carbonyl of the other. This is nothing but the aldol condensation, okay, intramolecular aldol condensation. So, let us see first, let us try to draw the enolate from one of the carbonyl from this hand. Okay. So, that will be say O minus, this is the double bond. So, that is the enolate, and on this side you have CO CH3. So, this is one possibility. Okay. And if you now do the cyclization, so this will be the flow of electrons, and what you will get is COCH3 here, and so that will become OH, and then there is a methyl, and this will be ketone. This is not the final product, this is the aldol, and then it will undergo dehydration. You can actually do this reaction in presence of base or acid. If you want to do in base, then you have to heat it a little to induce the dehydration. Otherwise, under acid medium, this will be protonated, and dehydration will be spontaneous. Okay. So, this is COCH3. So, this is one possibility. Okay. Now, let us try to define this reaction as per Baldwin's classification. So, this will be enol. First of all, the size, this is 1, 2, 3, 4, 5, 6. So, this is 6 enol endo exo trig. Okay. 6 enol endo exo trig. What the rule says? The rule says that 3 to 5, that means up to 5 enol endo exo trig is disfavored, but not this one. So, this one will be favored. So, that is a favored process. Okay. Let us try to see other. So, at least this product will be found for sure, but what are the other possibilities? The other possibility is that I can just change the two hands. Like other possibility is that you have COCH3 here, that means the top group I am writing on this side, and here CH2 COCH3. Earlier the aldol condensation was happening between this and that. Now, the aldol condensation I am trying to do between this hand and the enolate generated from the same. Okay. So, you basically you change the two hands. So, here it will be CO CH3, and this will be CH2 CO CH3. Okay. Now, if you want to do this reaction, now there is a possibility of an aldol condensation like this, and then followed by dehydration, you will be getting a 5-membered ring. Okay. And very similar type of system, alpha beta unsaturated carbonyl system, but that is imposed on a 5-membered ring. Now, let us see that what is the process. The process is basically, again it is now a 5 enol endo exo trig. Is that allowed? Is that disfavored or disfavored? What it says? It says that 3 to 5 enol endo exo trig. So, this is 5 enol endo exo trig, that is not a favored process. Okay. So, this process, whatever product, actually the product that will come out of this, I can write that the product will be double bond O, here there will be a double bond, this is a methyl, and here there will be this CH2 CO CH3. So, this product will not be obtained because it is violating the Baldwin's rule. Okay. This is a very good example that we have. Other problems or other important points about Baldwin's rule, that when the nucleophilic atom, usually we are dealing with oxygen or carbon, or we are dealing with nitrogen. Okay. That is the second row of elements in the periodic table. But if you go beyond that, suppose you are having this type of cyclization or attempting this type of cyclization like CO2Me double bond, and then you have say OH here. Okay. If you try to do this cyclization again in presence of base or acid, both are possible agents, okay. But this reaction does not happen because it is nothing but a 5 endo trig process, which is not allowed. Okay. On the other hand, if you have now instead of oxygen, if you have sulfur here, the thiol, if you have a thiol, then this reaction takes place, okay. Because of this, as you go to the third row of elements, then your bond length increases, okay. If the bond length increases, then the type of restrictions that you are having when the bond length was smaller, this oxygen could not attain the could not make the trajectory that is imposed by the Bargy-Dunij trajectory of 109 degree. Okay. That is not possible when you have a small a bond which is of smaller length, but as you put sulfur, the bond length increases. So, that gives more approachability, and the sulfur now can adopt the Bargy-Dunij trajectory of 109 degree and then form the product. So, in this case you will form this thiophene, the reduced thiophene product like this. That means, this is, so if somebody says that if 5 endo trig, this is nothing but 5 endo trig process is whether it is possible or not at all, you will say that yes, it can be, it is possible if you have a longer bond length involving the nucleophile attached to the carbon, and that happens when you go beyond the second row of elements in the periodic table, like in case of sulfur. So, obviously, this if sulfur is replaced by selenium, that reaction will definitely happen. Okay. So, so that is another important point to note here, okay, regarding Baldwin's rule. So, this is applicable for second row of elements, okay, second row. Now, let us let us go back to the problem, which let me see what is this, yeah, okay. I told you about this oxygen sulfur that system, but if you have the nitrogen now NH2 and then double bond and CO2 Me, here the nitrogen again the CN bond is short, is relatively shorter than the carbon sulfur. So, here also this 5 endo trig cyclization does not take place. So, what happens here, that this takes the other conformation NH2 OMe and then the double bond here. So, now the nitrogen attacks here in a 5-exo trig process, okay. That is allowed, that is an allowed reaction. So, that so it forms an amide instead of that nitrogen adding to the double bond. Okay. Now, this could have happened with oxygen, provided you have much more forcing condition. Okay. Nitrogen is a better nucleophile. So, this happens at a much less stringent condition. So people isolated the amide, the cyclic amide, but for oxygen definitely that reaction will happen, but you have to raise the temperature. Okay. The other type of example that I have is yes, this one. This is an I want to show this is also I think we have discussed this last time, that if I try to do this cyclization, this is nothing but enol 5 enol endo exotate. What was written here? 5-enol endo-exotate is not an allowed process. Okay. So, this will not take place here, it will just the O minus will act as the nucleophile and then will displace the bromine, and that will make it a. So, if you have the double bond on this side O minus, so now the O minus will act as the nucleophile. So, that will form 1, 2, 3, 4, 5 again the 5 membered ring, but it is 5 exotate which is allowed, 5 exotate is allowed. Okay. So, you get the ether. Let us try to visualize this, the cyclization processes, some are allowed, some are favored, some are disfavored. I told you that because some stereoelectronic requirement cannot be met as the that depends on the structure that you are handling. Okay. So, I want to show you a model, and then you will realize that why Baldwin came out with his rules and what is the rationality. Okay. Why certain stereoelectronic requirements cannot be met. Okay. So, the example I have here, this is my model. This is basically, this is a carbonyl, that means an ester. So, this is my CO, C double bond O, this is oxygen and this is the methyl. So, it is a CO2 Me group. Okay. And then you have the next carbon has a double bond, the next carbon has a double bond, then you have a CH2 and then you have another CH2, and think that this is a nucleophile like NH2. Okay. So, the question is, there are two types of possibilities. Okay. Let me write the molecule first. The molecule is C double bond O, OMe, and then a double bond, and then CH2, CH2, NH2. Okay. So, there are two types of cyclization. This problem just now we have done that. Here one possibility is that this attacks this carbonyl and finally the methoxy leaves, that gives the amide, that is the lactam. Okay, the gamma lactam, because it is a 5 membered ring. The other possibility is that it can take up another conformation where you have the double bond on this side, and this is the CO2 Me. Okay, and then you have CH2, CH2, NH2. Okay. So, this is the other possibility where the nitrogen attacks in a Michael fashion to the double bond. Okay. So, obviously, we know that this is not going to take place because it is a 5 endo trig cyclization which is disfavored, whereas this is a 5 exotrig process. Okay, because that is, it is attacking the carbonyl. So, 5 exotrig process, and that is the one which will be allowed. So, let us see the model again just to fix the atoms. So, this is the carbonyl, again I repeat, this is the carbonyl, this is the ester group, that oxygen and CH3, and this is the double bond, and here you have the CH2, CH2, NH2. Now, if you want to do the attack at the double bond, that means this is the double bond. If you want to attack the double bond by the nitrogen, with the help of the nitrogen. So, this is my nitrogen. So, the nitrogen has to attack it at an angle, at a trajectory of 109 degrees. So, basically it has to come on this side and then attack from here at this carbon, which is not possible because it is, the length is too short. Had there been another carbon and then the nitrogen, then possibly it would reach. Okay. And I told you also that if it is it is not nitrogen, if it is sulfur, then the bond length will be more. So, then the sulfur is able to reach this carbon and follow the trajectory that is demanded by the stereoelectronic requirement. Okay. So, this reaction, the nitrogen is not able to, because if you want to do it, then there is lot of strain. If you want to do that trajectory, you see the strain that is imposed in the molecule. Okay. On the other hand, if you now switch it in this way, that this is my carbonyl, that ester carbonyl, that is the ester, and CO and OMe. Now, what we are saying that this is now allowed. Now, you see the nitrogen is basically you can bring it right at the top of the carbonyl. So, now this type of trajectory that 109 degree to 109 degree and is possible because the nitrogen is right on the top of the carbonyl. You can bring that in a conformation without inducing any strain in the molecule. Okay. So, it is basically that trying to satisfy the stereoelectronic requirement. If you think that lot of strain is developing because you are forcing that the centers should reach each other and then satisfy the stereoelectronic requirement, then that is basically disfavored. On the other hand, if you see that if the trajectory can be made without much deformation, then that will be favored. So, that is exactly, that is very clear from this model. The carbonyl nitrogen can reach very easily. On the other hand, the double bond, it is not possible because it is endocyclic. If you see that it is now difficult for the nitrogen to adapt this 109 degree. So, that is the basis, and I wanted to show you through a model like this. So, I think that ends up the this cyclization rules and the related problems, related issues, and next we will move on to another new topic. So, that finishes up the topic which is basically broadly under the heading of stereoelectronic effects on conformation and reactivity of organic molecules. Thank you.